Welcome to another episode of my show, William Wallace for America. In this episode is a guest that I've had on several times before who has not only a unique perspective on being a Christian libertarian, but a perspective from a person who is a software engineer. That's my guest, Ben. He's a software engineer for big tech corporations. So in this episode, he has actually been inside the data centers, worked inside of them, been involved with them. And I think you are going to get a very, very unique perspective about them. Some really important and facts and information about them that I think you're going to want to know. As I've said along, I'm not against data centers because we all use them, whether we like it or not, whether it's Facebook, Google, or whatever. But we want the data centers to be environmentally friendly in a symbiotic relationship with our nature and our land and our water usage and all that other stuff. And I've talked about that before. This episode is going to offer you a unique way to look at them, think about them with information that I think may not necessarily change your opinion. It might just give you a different perspective. Today's episode is brought to you by Revere Payments. If you're tired of your type of business being canceled, like if you're in the gun industry especially, or you want to save some money on credit card processing, go to reverepayments.com/WWFA to find out if they can save you money. Ben, thank you so much for being on the show today. I really appreciate you, sir.
Yeah, great to be back here. Thanks for having me again.
Well, from the day I met you as a Christian libertarian and started reading your information, which I strongly recommend that everybody goes to your site, Christian Libertarian on Facebook, and just sees the stuff you put out, I think they're going to find somebody who doesn't go, well, you're a libertarian, so you're not going to be right nor left. You're really just kind of a freedom liberty guy. And now you've been talking a lot about data centers and how that affects freedom and liberty and the opinions of what we know. Let's give it a start with what you want to answer on that, but then segue into how you got your start with the data centers.
Yeah, so I did a 6-part series on data centers that I posted on my page, just because this is such a hot button topic recently, and I think the libertarian approach actually has some interesting perspective to add in here. But you know, I think that a lot of people are kind of poorly informed when it comes to actually how our tech infrastructure works behind the scenes, why tech companies are making the choices that they do, where data centers are located, and why that is. We often hear statistics about, oh my gosh, every chat GPT query uses like a half-liter bottle of water and statistics that frankly scare us. And so just want to like unpack that and go through that. And why care about my opinion or what I have to say? Well, I have a master's degree in computer science, and I've worked for one of these large tech companies for 15 years, specifically inside the data center space. So I write the software that actually helps people actually deploy this capacity inside the data center, that helps maintain it, detect when things are broken, get it fixed, decommission it, maintain data security throughout the life cycle of that hardware, all those different pieces. And so for 6-7 years of my time with this company, I physically sat in one of our data centers in the office space area and had access to walk out on the floor, to look at the hardware, to watch the people actually doing the maintenance, doing the deployments, doing the decommissioning. So people could literally come to my desk and yell at me when things were broken. And so now I work from home, but I am several miles away from 2 different large companies' data centers. And here where I live in the Omaha metro, like Google has actually an enormous footprint. And we'll get to why, but there's actually a whole bunch of different data centers kind of along the I-80 corridor in Nebraska and Iowa. But we'll hit that up a little bit later.
I like to remind people too, that I've had the chance to talk to you about a little bit more, is that people listening to this might go, oh, he's going to be all for the data centers because he works, he's worked in one, he's a software engineer. But I'm going to double down on this, and I want people to listen to what you have to say, because you really have a real benign opinion, not because you're defending them or against them in any way. You've just been in there and you're just going to give very factual information and some unique perspectives that I actually have changed my mind a little bit.
Yeah, so I mean, I want people to actually understand what's going on because we shouldn't just respond politically to hysteria. We should actually understand what's happening here. And so if I had a conversation with a guy that I went to youth group with when I was a kid, who's now a city alderman in a city in Wisconsin, and he was like, "Hey, there's all this data center stuff going on. Like, hey, can you just tell me about this so that I can actually have a somewhat informed opinion going into all of these policy discussions about it?" And so that's mostly the approach that I want to bring here is let me try to explain a bunch of the technical side of things, the reasons for why companies are making these decisions, even some economic analysis towards that end. And then I will have kind of a Christian libertarian take on it at the end, but I mostly don't want to be prescriptive about saying what we should or shouldn't do. Does that make sense?
Yeah, yeah, that's up to me. I
Okay,
want that
so I guess
symbiotic relationship, but go.
yeah. If you want to bring up the first image, we can kind of jump in.
Absolutely. So what I like though, some piece of information that I'm aware of before we brought this on air is before and I'll be bringing the image on here while you're talking about giving the answer. We'll say is how long data centers have actually been around, and where
Oh
were
yeah.
they before we started seeing the clear cutting of farmland? You
Well,
know.
I mean, so data centers have been growing and have been in use for at least 25 and even more years than that. So, kind of in the 60s and 70s when we really started developing computing infrastructure, you usually had mainframe systems. And these could exist in government facilities and private businesses. And so, if you were a business that actually had this compute capacity, you probably had your computer room or something like that, which
Right.
essentially was your own small data center inside your office facility. Fast forward to say the 2000s when the World Wide Web is really starting, the internet as we know it is being born. All of those websites that you went to, well, not all of them. Sometimes they were still hosted on your corporate network in a rack inside your building, but more and more these were actually being pushed out to co-location facilities that actually were like, hey, we just have a whole bunch of web servers and you can buy a entire server, an entire rack, or just a slice of one server to serve your website, your e-commerce site, whatever you're actually doing for your web footprint. And so this was really kind of the birth of the data center, was when we were like, well, instead of I have my computer equipment deployed on my facility, we were saying now I'm going to rent equipment, so to speak, in somebody else's facility. And then in the 2010s, we really had the birth of what we might start considering the cloud. And so this is things like Gmail, where it's like, well, instead of my email being in software, Outlook downloaded to my computer, I'm going to have my email stored out there in the cloud so that I can just access them from a phone, from a computer, from whatever. And then from the infrastructure standpoint, businesses were like, well, and it's expensive to actually maintain hardware at my facility, to maintain the right environment for air conditioning and things like that, to maintain the power requirements of that, let alone that there's problems with, like, say, fault tolerance. Because what happens if the internet to my site gets cut off because somebody digs in the wrong place and cuts the fiber optics, or the power to my building goes down? Like, I don't want my e-commerce to go offline because my little city actually lost power for a few hours. And so more and more people were like, no, let's push this out into the cloud. And then especially the reliability aspect. If I'm running a single server at a single location, that's not very resilient. And so there was a lot of push about, like, hot failovers. How do I have two different places where this could be operating? And if one version goes down, the other can seamlessly pick it up. And then there was kind of a push even more than that to say, well, how do I actually think about reliability zones? How do I think about global performance, especially as we had more and more tech companies having a global footprint? So how do I serve this globally, all around the world, maybe at different facilities around the world? And then any given one of those facilities could literally go offline and nobody no end user should really notice, other than maybe the ping time or transaction time takes a little bit longer.
Yeah.
So we've been steadily on this movement to say, instead of having the compute capacity sitting, on your desk as a full powered computer, now we're using phones. Now we're using, very lightly powered laptops, Chromebooks. Microsoft kind of has their own lightly powered version, where most of the computing is actually done out there in the cloud, and I'm just, using a web browser to access it today.
Right.
And even traditional things like Photoshop, which you would have needed a fairly high powered computer to use locally. Now you can subscribe to Photoshop and use it in the cloud. And so Adobe is running Photoshop on their servers,
Mm.
and you're paying a monthly subscription to access it. And you can do that, photo editing from your phone, because all the compute capacity is out there in the cloud. So like we've been trending this direction for a long time, and really over the last 25 years, there's been a tremendous growth in data centers. And so a lot of the conversation about this is very recent and very driven by artificial intelligence. Like, up until about 3 years ago, nobody that I knew of was really outside of the industry was really talking about data centers. And so I, in my opinion, a lot of the opposition to data centers today is actually tied to artificial intelligence. People are afraid of what this is going to do to their jobs. They are uncertain about this new technological leap forward. And so, I can oppose this new technology and all of its unknown effects by opposing the buildings that actually make it happen. And so I think those things are fairly tied together.
I could agree with that 100%, but I think that there is another 100%. I think that there are people who all of a sudden, now the clear blue sky, they start hearing about data centers. They didn't know. I think the average person did not know about data centers. I think they just believe, okay, I all this computing is done in some office building where the company is located, and they didn't realize that there were data centers. And now that we're seeing data centers go in and clear cut, 100 acres of land out in some pristine mountainside. That's what we hear about in the news. And
Mhm.
and maybe there's not that many of them. Maybe, and I'll let you answer that question. But now we're seeing, somebody do a news special. They're standing on the side of a hill, and this data center is going to clear cut, 250 acres or 500 acres of trees. They're going to kill the wildlife. They're going to suck all the water out of the ground. Nobody for 100 square miles, exaggeration, is going to have clean water to drink, and they're going to kill all the animals. And we see that news story, and then we hear all the other stories where data centers are going into states and clear cutting land and doing what they're hearing in the big story. So I think there's a lot of people who don't want the pollution. They don't want the EMF pollution. They don't want the water usage. They're worried about the scarcity of electricity and water as a result. So now I think that other
Mhm.
100% focuses on the people who are worried about the environmental impact, and still, like the other 100% of people, don't even realize that data centers have been in existence for 20, 25 years. We're just seeing them done a little bit differently. Can you explain that or help me unpack that?
Well, I think we will actually naturally unpack a fair amount of that if we kind of progress through the different images,
Do
and we
the
talk about
slides. Here we
that.
go. I'll
Yeah,
bring
yeah.
that's a great segue. Here's
This is
slide
number
number,
6. Let's go to number 1.
let's see, is that, do I have them backwards?
Yeah, this is number 1. Okay.
This is number 1,
Um,
okay.
yeah, so really this post was meant to say, hey, there are real concerns here. And so let's kind of talk about some of them. Like power demand. Yeah, some of these data centers are pulling as much electricity as 100,000 households. This is very real and true. I think what we need to think about is, in the 90s and 2000s, when we all had fairly high powered, high electricity computers sitting on our desks in office buildings, we were concentrating that power use, or I should say, we were distributing that power use all over the place. Like, the energy consumption in an office building when everybody had a full powered desktop was fairly large. And now we've kind of shifted that out and we've put that in a data center. And we're like, you can literally have a small tiny box that is your computer that only uses 100 watts of power sitting on your desk. But now that compute power still has to exist somewhere. Now it's just been concentrated off in this big data center building. So are we using more power today? Well, yes, because we're doing more computer related things today than we had back then. But you also need to keep in mind this. Well, it used to be lots of power consumption distributed everywhere, and now we're concentrating a bunch of that inside of data centers.
So in other words, instead of having millions of those hard drives that would stand 18 inches tall and about 8 inches wide and about 18 inches deep, sitting next to your desk or on your desk, we have all those concentrated in one data center location. So a
Right.
good analogy to make, I'm glad you said it that way, is were we using the same amount of electricity spread out, let's just say 1,000, you know, hard drives equal one data center. It might be 10,000, I don't know, but just for ease of purpose. So instead of having 1,000 hard drives in 1,000 different locations, now they're all in one location. Were we using the same amount of electricity and water before, even though you weren't getting water in your desk? Were we using the same kind of amount of environmental impact, I'll say, being in 1,000 different locations as it was in one location?
Well, maybe not water, but power probably. Because you didn't use water cooling for your home system, right?
Right.
You just absorb that heat in the air conditioning. But that brings us in, to an interesting question, because like the power and the water are actually tightly connected, and people don't really realize that. Why do data centers actually use water? I thought water was the enemy of electronics. Like,
Right.
what are we doing with this? So there's really three different ways that you can cool a data center. One is traditional air conditioning. Essentially, then you're saying, I'm going to use all this electricity that turns largely into heat inside the chips. And then I need traditional air conditioning to provide the cooling power, so that those chips don't overheat and fry. Essentially, that means for every, say, 100 watts of chip energy use that I have, I need 100 watts to run an air conditioning unit to cool that off. So I end up using 200 watts of electricity to provide 100 watts of compute resource. Now, if we switch all the way to evaporative cooling, this is essentially where we say, hey, I'm going to use the natural process of a water evaporating off into the air, which provides cooling, right? Water has to absorb a tremendous amount of energy to go from its liquid state to its gaseous state.
Mhm.
And so let's make use of that to actually provide the cooling for the data centers. If you do this, you can use about 110 to 125 watts of power in total, instead of 200 watts of power, to provide that 100 watts of computing, right? So
Okay.
it's actually super power efficient to evaporate off water and use that as your cooling mechanism. Okay, but now you're using water. You're pulling water out of your municipal water systems, out of wells, out of rivers, lakes, aquifers, right? And this is where a lot of people are very concerned about the water use. Now, it's evaporative. It's going off into the water cycle, right? It's going off into the atmosphere. It's going to come down as rain somewhere else. It's not like we're consuming water and making it no longer be water, but there can still be very valid concerns about this water use, especially in more arid regions. We have large regions of the United States that have been under drought conditions. Like, what is the impact of that? Um, then to finish this line of thought, so there's kind of three different ways we said. One was traditional air conditioning. On the other side was evaporative cooling. In the middle is where we actually use water to transfer the heat from inside of the data center to outside of the data center, and then we use like large radiators and fans without evaporating off the water. And so in this case, where it's called closed loop cooling,
Mhm.
where we're using water to actually transfer the heat, and then we're using radiators and fans and things like that, as a way to
Cool it back down.
transfer the cool the water back down so that it can go recycle. So this is more efficient than traditional air conditioning, but less efficient than evaporative cooling. And it also requires you to build a lot more infrastructure, often with expensive equipment, because what are some of the best metals for doing that kind of heat transfer? Copper. And copper is super expensive right now. So there's a fairly large cost to actually building the closed loop infrastructure. And so again, it's more efficient than traditional air conditioning, but less power efficient than evaporative cooling. And
Is
so,
it?
go ahead.
No, do you think this is an area, one of those areas where I said that I think that part of what people's fears are is the unknown, but also they're worried about what they're hearing in that one news story. And I'm not saying that doesn't exist in every data center, but using that thought process, is there a way to bring more people to the table to help to work with AI to not only for that symbiotic relationship that I refer to often, but in a way to ask them, hey, can we look into other cooling methods instead of using our natural resources, our water? I know technology has got to exist. It's got to be right around the corner for there to be other methods that do not have the drain on our environment and our water supply.
Uh, I mean, maybe. At least from a thermodynamic perspective, there's a limited amount of options that we really have for handling this kind of a thing. And so I know in I think it's Google has a data center in Finland, maybe, and they actually were able to connect the data center into the municipal infrastructure because at least in some of those Scandinavian countries, they essentially put in like citywide hot water boiler systems because it's so cold up there in the north all winter long.
Yeah. Yeah.
And so all of this excess heat from the data center now actually provides municipal heating for the general public. And so there are some interesting creative ways that we could be symbiotic. I think it was my father-in-law who was like, "Hey, making cheese actually requires warming all of that milk up so that you can actually make the cheese. Why couldn't you put cheese factories and data centers next to each other so that they could actually reuse that heat instead of using gas or electricity to actually heat all of that milk up to make the cheese?" And I'm like, that's fantastic. And I think maybe in time we would see the free market actually develop some of these synergistic opportunities between businesses that are creating heat and businesses that need heat.
Or like to your point, in cities, in cold northern cities, a geothermal pipe system could run through the AI data centers and return that water to homes, in a geothermal type of heating system, where those
Yes.
warm pipes that are circulating that warm water for the data centers are being used to heat up homes. And then as they're returned back to the data centers, they're running through through a cooler ground
Yep.
system or a colder environment and cooling the water back down for the data centers to use.
Yes.
Another one.
So I think there are symbiotic ways that we could actually use this heat in a beneficial manner. But again, a lot of this is fairly new, and especially the AI data centers have generate so much more heat than traditional data centers. And so I do want to touch on the water use. Lots of times you hear statistics and you don't understand how to put them in context, and so they can sound extremely scary. And so a traditional data center that was like storing your Google Photos or providing your Amazon shopping queries or things like that, those kind of a data centers, an entire data center facility would use about as much water for their evaporative cooling annually as a 18-hole golf course would use to keep it green, right? And so when you think about it in that perspective, it's actually not as much water as we commonly use for everyday things that are all around us already.
So
Um,
wait, so
AI,
an AI data center is equal to one golf course?
no, well, an AI data center, a traditional data center, is about equal to one golf course. An AI data center is about 2 to 5 times more power density, and so about 2 to 5 times more water. So 2 to 5 golf courses for a large AI data center facility.
So for everybody who's worried with the data centers, look at the golf courses that are using, or 5 golf courses use as much water, and we have tons more golf courses than we do data centers. So we're looking at more water usage, and I'm not trashing golf, and I don't play golf, but either way, for my golfing friends, I don't hate golf courses, but in general, a golf course now, from what you're telling me, 5 golf courses equal 1 data center in water usage, but the golf course is dumping chemicals and fertilizers constantly, daily. So, and looking at that, they probably have a higher environmental impact on pollution in our groundwater than does a data center.
Correct. And so, I mean, I don't want to downplay a data center is
Yeah,
essentially a light industrial facility that consumes an enormous amount of electricity. Um, and so, this is why they're often put away from everybody else. They're uh, often put into like commercial, business parks or things like that. Um, but from a environmental impact perspective, there are a lot of common things in our everyday life that are as bad or worse than a data center. All right,
wow. So
so
yeah, not in my backyard.
so a lot of the sentiment comes, some of that is the concern about chemicals, and again, there are chemicals. Like most data center facilities actually have on-site power generation to handle cleanly shutting everything down, or at least keeping things running for a number of hours so that they can drain the capacity if like your power grid access to power goes down. And so you have a bunch of on-site diesel to run all of these diesel generators, and that creates fumes, and that creates noise, and there's concern about diesel storage leakage or things like that. There's noise. Now, generally speaking, an evaporative cooled data center has very little noise. The noise is either going to come because you're running air conditioning units, or you're doing the closed loop cooling and you need fans to blow air across the radiators, and that's going to create noise. Or instead of connecting to the power grid, you actually are generating your own power. I know some of Elon Musk's data centers, I think for X, he has his own natural gas turbines to do power generation. Well, those are noisy. Like,
Mm.
and so noise pollution is a real concern, but again, a lot of that depends on the technology that's actually deployed on the data center. If you're using evaporative cooling and you're plugged into the power grid, there's probably like no noise. Aesthetic footprint, you know,
Right.
these are big metal buildings, pretty much like any industrial facility or factory, that don't necessarily look pretty. I know one of the Google facilities along Interstate 29, south of I-80, they actually put this huge mural up on it. They hired some artists to come and paint the entire side of this one data center so that it doesn't look so ugly from the highway. Um, but there are some concerns about this. But this is also why when you were talking about, oh, the data center is clear cutting 250 acres of land. Well, most people don't want the data center next to their housing. We
Right.
understand that, right? That's why we're buying land and building it away from your houses, generally speaking, or we're
But
putting this in industrial parks or things like that.
so could a data center essentially, I know that it's look, from a construction point of view, it's probably easier for a data center to come in, clear cut, a couple hundred acres, build the right foundation, design it exactly the way they want it, and build it brand new, instead of taking over these abandoned warehouses or abandoned facilities that are decaying all over our country,
Well, there
and
there there
are
is
looking
a
really ugly
fair
and
amount
coming
of
in.
that that's actually happening.
Oh, is there?
So yeah. I know out in Pennsylvania, there are several different data center facilities that have taken over old industrial facilities because, especially like if you're going to build a data center in a big brick building that used to be a foundry, you probably already have all of the power capacity run to this facility that you're going to need. You probably have the cooling that you already need readily available, and so they are taking buildings. I'm pretty sure it's Google who actually took over like a big old Gatorade facility and turned it into a data center. And so
Nice.
there is some of this happening.
I love hearing that.
It's
Yeah.
it's not all build it from scratch.
Okay.
Although I think there can be complications for that. Some of these racks, having personally been on the data center, some of these racks are fairly heavy. Um, they you don't want them to get out of skew because that can impact, pulling cables out of place or things like that. And so you need a pretty level floor to actually move this stuff. And the levelness of a floor inside an old foundry or a Gatorade manufacturing plant might not actually be good enough. And so you might have to do things to like relay the floor to be like, hey, I need 500 feet of floor with less
Mhm.
than 1 inch of variation or something like that, right? And so the specs that we might want in a modern data center and the specs that we would get in some of these other facilities may not match up, but people are trying to actually make that work.
Well, looking at looking at your. I know we're at the bottom of your first infographic that we have on the video version. For those who listen to the podcast version, there's a video version on my YouTube and Rumble channel that show the actual infographics that we're talking about. Number 3 on this infographic, our first infographic, says AI anxiety, economic displacement, and corporate welfare. Do you want to talk about that?
Yeah, and I'll even add a third one that I didn't include on the image, which is like people who are worried that data centers are just AI or government surveillance facilities. So economic displacement. There's a fear that AI is going to replace jobs, and so people are super worried about AI. And one of the ways that they can take out that worry is by opposing AI data centers. And that's kind of a natural thing, but I'm not sure we should actually be considering a new technology that way and opposing it this way. And then corporate welfare, like there is certainly situations where states or counties or cities are offering tax abatements for data centers to come in and build. And especially as a libertarian, I don't like that kind of corporate welfare going on, right?
Right.
You should make your choices about where to locate your facilities without begging some local government or state government to give you a tax handout. So
And I'll
I think
comment
that's
on that. I can certainly understand a business looking and accepting the handouts. I get more upset about the politicians that are offering them because they're usually on one side offering this corporate welfare instead of offering that same incentive or tax breaks to small businesses that are already in the state or the taxpayers that have been footing the bill that have been getting manipulated through the politicians, promises and failures to deliver. But that's just my opinion.
yep. And then the government surveillance perspective, like some of this is because of the third party doctrine exception to the Fourth Amendment. That essentially the Supreme Court said, if a third party has access to say your electric billing records is public knowledge, and so the government only needs a subpoena to get those things instead of a search warrant. But your data, like the files you've stored in Dropbox or your Chat GPT history, those are actually still protected and require a warrant for the government to access. And so I think some ways by strengthening our Fourth Amendment protections, we could address some of these things. And then some of the concern is like AI can actually join disparate data to make a profile of you that no human could assemble. That's true. That's a very real concern. How do we constrain the government against doing things like this? And then another thing that I've heard and I've had to debunk multiple times over my 15 years working in this data center space is the claim that, oh, data centers have a direct line to the NSA or to the government surveillance apparatus. And it's like, no, they don't. That would have to be very clearly part of the design of the data centers to actually have that kind of infrastructure, and it does not exist. The government has to present a subpoena or present a search warrant to these tech companies to actually gain access to your data.
So let's see this would so that was that gives us number 1, right? So we're gonna go to number 2.
Perfect.
Let's see. Is this number 2?
This is number two. So number two really wants to say, hey, let's actually understand that there is not a uniformity in data centers. Data center can actually mean lots of things, and there's many different reasons for the different parts of infrastructure that are actually deployed. So most of the time when we're talking about data centers, people think about number one. This is where huge businesses, hyperscalers, Oracle, Microsoft, Google, Meta, etc., are building their own custom facilities. They're buying 500 acres of land, building their own buildings with their own infrastructure, deploying their own hardware inside of them. They control everything about that facility. Um, Number two, though, these are cases where instead of building, procuring the land, procuring all the appropriate permitting, building the facility, a third party actually does that. And a company like Oracle or Microsoft might say, hey, we need more capacity faster than we could actually buy the land, get all the permits, clear the land, build the buildings, which is, a multi-year process. And so these companies like Digital Realty, get all those permits, get all the power hookups and everything, build the shell, and then they're going to lease that building to Microsoft, Oracle, Google, whoever, to actually deploy their capacity into that building. And so generally, these are smaller than the custom owned facilities. And then there's what we call colo. This is kind of traditionally what we would actually think of as a data center going
Co-location.
back like 10, 15 years. This is a building that says, hey, I'm a data center, and you could come and you could own as little as one rack that's in my data center, or entire rooms with whatever infrastructure that you want to deploy inside of there. And these are actually common and very, very useful for, hey, I'm a business. I'm going to run an e-commerce site. I actually still want to own my racks instead of going to the cloud, but I don't want to own the air conditioning and the power redundancy and the internet redundancy. So I'm actually going to, get a rack or a couple of racks in a colo facility. Or situations where company A actually needs close access to hand off data to company B because they're just synergistic between them for some reason. And so having both of their compute infrastructures in the same physical building, feet, meters from each other, is a great way to actually facilitate very quick data transfers between, these two companies. So you could think of ways where you integrate Chat GPT with other websites, and maybe it reads your Gmail and does things with your Gmail. And so how do you get your Google email and Chat GPT to be able to read and operate on that without necessarily moving as much data across the large public internet? So these kind of sites are all over the place and have been for 25 years.
What
So
about
there are a lot of
the
colo
edge
facilities.
sites? Is that what you just now
So
covered? The edge sites?
I haven't touched on edge sites yet.
Oh,
So
okay.
this is something that a lot of people don't even realize exists at all. Um, Companies like Google, Microsoft, Netflix, Hulu, or Disney, etc. Right? If you want to be able to access things on Facebook quickly, watch whatever is the most popular reel that's going on. Watch whatever this most popular YouTube video. Right? These large companies don't want to move all of that data across the public internet. So what they actually will do is they will put small edge sites. This might just be a rack of computers that largely serves as a cache for whatever is popular. And this might literally sit on the edge of your Comcast network, your Cox network, your AT&T, your Verizon cell towers, in the basement of a business, right? And so these are going to be all over the place to cache that data, and that way to actually use less power in total, and for you to have a better user experience. Because instead of moving this, say, from a data center in Taiwan all the way to you sitting at your desk in Texas, this is actually served from the edge of your ISP, which only might be 20 miles away. And
Are
so
these the type of
much better
sites that
experience for users.
Are these the type of sites that we hear are in the basements of a business in our town, or maybe
Yes.
the municipality has an extra floor in their 10-store building that they have they have one of these data centers in that we don't even know about,
Yes.
which must be using traditional cooling, but that's a whole other story.
Usually, yes. Yep. But the point here is real-time application. And so you want that data to be as fast as possible. This is especially important in like real-time things. So even this video conversation that we're having right now, if it was laggy, it wouldn't work so well. And so there's optimizations from having these edge facilities that make this kind of stuff work better. And then, if you're say using a AI translate, um, you want that to be real time. If you're trying to talk to somebody who only speaks Spanish, and you're trying to have a conversation back and forth through an AI translation tool, you want that to be as close to real time as possible. So you don't want that data having to move to the other side of the country, let alone the other side of the world, to actually answer that query. You want that happening as close to you as possible.
How about these specialized data centers in this infographic that I'm looking at?
Yeah,
HPC
so I mean,
clusters, modular DCs, and dark sites.
yep. So dark site really means that this is a building that doesn't have regular staff inside of it. So some of these, especially the edge sites, like they might only have staff that come visit them every couple of weeks. Even some of the colo facilities might only have staff that come visit them every couple of weeks. Modular DCs is a way to say, hey, we need something built so fast that we're going to actually just deploy this in like tractor trailer containers, and we're going to wire the power and the cooling to these things, and boom, we've got some racks. Now, sometimes you need this local, like you might have this happen in a case of like a hurricane hits, and the Red Cross is going to literally take some container trucks full of data center equipment to a local facility to facilitate like identifying people, connecting up families that got disconnected, all that kind of things. Some of this is for things like the Olympics. Like all of a sudden, we need all of this capacity for sorting out all of the video, making sure all the websites are updated with live stats about these games that are going on in the Olympics. And so we're going to bring all this extra compute capacity in there in, containerized units for the duration of time that this event is happening. And then it's going to distribute back out. And then HPC clusters. So we'll kind of talk about this, I think, in the next slide a little bit more. But a traditional data center is somewhat different than an AI training data center. And so the hardware that's actually deployed, the amount of electricity that's consumed, the amount of heat that's generated is very different if we're actually doing the AI training.
Okay.
So any more questions on this? Otherwise, we can go right
economic logic, market response.
Yeah. So trade-offs, like if I want to actually own the end-to-end about the facility, I want to build that enterprise place, right? I'm going to buy the land, build the building, put in my cooling infrastructure, put in my network infrastructure. I own everything inside that facility. And so there's some very good economics that actually come with building those large facilities. And then on the other side, there's an economic reason for those edge sites. Yeah, they're probably the least efficient of those sites. You're paying the most probably for putting your server racks inside of them. But when latency matters, what you want is customer satisfaction. And so you're not worried about the cost.
Right?
Yeah, well, the colo or the edge sites in particular.
Yeah. All right, we got slide number 3, I think. Let's see if this is it.
Okay. No, so the AI one is the next one yet. But this one is like, why do
let's see
data centers where they are?
Let's see if I can find 3. That's 5. Where did
No. You were on it. So 3 is actually where we put the data centers, and 4 gets into the different kinds of data centers for the different parts of AI.
That's 4. They get mixed up. Is this 3?
Yeah. No, that's 5.
That's 4, 5. Somehow or another, I'm getting them there. Let's see. There's part 6. There's 1.
That's 2.
That's 2. That's just one we just now went over.
Yeah, here's 3. So let's
stay here for
a minute. Yeah. Okay. Why are data centers actually placed where they are? So there's actually a bunch of reasons.
The science of site selection, the 5 pillars for modern data centers. I like that.
Yep. So number 1, do I have access to the electrical energy that I need? Right? Why might you be clear cutting 250 acres of timber out in the middle of nowhere? Well, probably that's because it's actually next to maybe a dam, and so you can get cheap hydropower electricity. Why are a bunch of these, data centers are... Sorry, if we back up a second, when we think about electrical transmission, we have power generation, we have transmission of energy, and then we kind of have the local distribution network that brings the power to your house.
Right.
And so there's these 3 components. Transmission actually wastes an enormous amount of electricity. To move power long distances wastes an enormous amount of power. So To minimize that waste, data centers often want to be right next to a power generation facility, right? I don't
Mhm.
want to have to build, power lines for 100 miles to get to my site
Mhm.
from where the power generation is, because I might then need 3 times as much generation for what I have consumption, because so much of it is wasted from the
Mhm.
resistance across the energy lines. So, being as close as possible to that power generation is super important. And kind of what we're aiming towards eventually. I know some of these companies are actually researching like next generation nuclear technology, and the hope would be that a decade or two from now, most data centers would actually have their own on-site mini nuclear power to power them, and would be
Yeah, I've heard
completely
about this.
off the
Yeah.
grid. Yeah. But that is not the case today. I know there are places where some of these big tech companies are trying to work with state lawmakers and local power companies to say, can you build me a power plant, and I will consume all of the power from that power plant in my data center that I'm literally going to build next door,
What's
right?
interesting is I'm not downplaying the stories of people that are talking about how a data center is moving into their small town where, they're on the edge of a mountain and, this data center is coming here. It's a clear cut 500 acres of this side of the property. But from what you're basically explaining with the power grid strategy, chances are right on the other side of the mountain that they're not showing in that news story is a power grid, power lines and businesses and industry that is located there for whatever the population is. And the AI data centers just say, hey, we're going to tap into that, but it just happens we're going to do it right here where there's land to get.
Yep.
All
So
right, you got number
part two.
two, dark fiber digital nervous system.
So this is the part that most people don't think about. You need an awful lot of internet bandwidth to get to run a data center facility, and chances are, what you want is you need some access to the public internet. But what you want is a whole bunch of fiber optics that actually connect your data centers together. And so, where does this dark fiber exist? Well, generally speaking, it's along places where it's easy to actually get, to lay these fibers, railroad tracks, interstate highways. Those are the two places where most fiber optics actually run. So, do you want to go build a data center out in the middle of nowhere? No, you actually need to run it somewhere where it's easy to actually get access to existing fiber optics or lay new ones. So you're going to be locating these data center buildings again next to interstate highways or next to railroad routes, because that's where you can get rights to lay these fibers.
I love it.
So this is actually why, if you kind of look at where a lot of big tech has deployed their data centers, it's a long interstate routes
I
because
understand.
of the
Now I
access to
see it.
dark
Yeah,
fiber.
now I see it.
Yep. Part 3. Okay. Do I if I'm going to generate a whole bunch of heat,
It's water, climate, and cooling balance.
if I'm going to generate a whole bunch of heat, do I want to deploy my data centers in Phoenix, where it's already incredibly hot and dry?
No.
No. Okay. I generally probably want to push them as far north as I can, because it's cooler there. Okay. But I also need to take care of, oftentimes people want those data centers to be close to where their businesses are located, so that they have low ping times. Ping
Mhm.
meaning the amount of time that it takes for that data packet to go from the data center to wherever the customer actually is.
Right.
Right. So there's this tension, like, hey, I could move things all the way up to the Arctic Circle and my cooling problems are largely solved. But hey, now all of a sudden it takes twice as long, which is going to make games laggy, Google query slow, right? All of those kinds of things. So what's that tension that I have between how far north I can move things because that helps on my cooling side, versus how close to population centers I actually need to be, right? So there's a balance there. 4, I need a labor pool to actually build these. So if we're talking about that kind of category 1, where somebody like Google is going to go in and build their entire site from scratch, you need a large labor pool to come in
Mhm.
to, you know, dirt movers who can level that land,
Right.
Concrete people who can actually lay and pour all of that concrete and build the infrastructure, pipe fitters and metal workers who can actually build all of the water cooling infrastructure that need to be there. An army of electricians to lay all of the power infrastructure and pull all of the fiber optics that are necessary. HVAC technicians who can do all the sheet metal work. Like for some of these sites, if they're actually in that brand new, I'm going to turn up the site phase, they might literally be drawing talents from 150 to 200-mile radius around to get enough skilled workers at the site to make this happen.
Wow.
Right. So you don't want to build this out in the boonies,
Right.
right? You need population centers to draw from so that you can actually get that kind of
Right.
trade talent. Right. And then you need your daily operations people, the people who actually can keep the water cooling going, the people who can keep the air cooling going, the people who can keep the electricity going, who can maintain the networks, who can maintain the actual machine capacity inside there. So
Right.
you don't want to be too far away from a population center, or it's going to be really hard to actually get a workforce of this kind of talent. So generally speaking, you're going to build these things on, little ways away from the outskirts, maybe a ways out of the suburbs where you can
Right.
still actually draw on a decent labor pool, but your land prices aren't insane. Right.
And then permission social license.
Right. So this is the question of like, do people actually trust you to be there? Can you actually get the zoning rules that you actually need? Can you tap into the water systems and the power systems without all kinds of like public debate and objection to it? And so, this is, I think, where the current debate actually sits. And a lot of data center capacity is like, well, should I go to this state? What about this state? There are some places like where I live in the Omaha area that has historically been very friendly to data centers, and so that's why there's actually a lot of data centers in this area, because the community has accepted it. Where they're like, yeah,
Right.
these are good jobs. We have a fairly large pool of that skilled labor that they can pull on to build these new facilities. The different municipalities have been very happy to work with these different tech companies to say, how do we deploy that capacity here? And so, at least in the area that I live, like we have really good social license on that.
Right. And like I said, when you talk about the community accepting it, if the AI data centers could find a way to use some of their byproduct, whether it's heat or whatever the case may be, to be able to give back and help the community in such a way, they're going to get more communities to accept it, and it gets them more in a symbiotic relationship with the environment around them. So now we're looking
Yeah,
for
and
slide.
yet there's a tension there, because a lot of people are like, well, put those data centers way out nowhere. But if it's out nowhere, then it can't actually have that symbiotic relationship, right?
Right.
So do you want that data center building in your industrial park, or do you want it to go buy that 500 acres of land 25 miles out of town,
We don't
right?
see
It
it.
could,
Yeah.
yeah, yeah,
But if they start moving them more into an area, like I can picture an area where I live, there's a very industrial area near me, and if they put and I know there's tons of empty warehouses there. If they put that there and they found a way to use the heat from it to cool to heat up the local businesses around there in the wintertime, to where it thereby cuts those businesses, electric bill or heat bill by half or
yep.
more in the wintertime,
People would be pretty happy.
people would be pretty happy, and it'd be a good and then, of course, you can find ways for that heat to generate other forms of electricity, whether it's through geothermal electricity or what the case may be, in such a way that it creates electricity, and let's just say they give it away for free. They're gonna build more partners in the community and get more traction, I think. All right, your part 4 infographics is training versus inference, the two brains of AI in their physical homes. This will be
Yep.
interesting.
So yeah. So when we think about AI technology, there are very much two different distinct parts of it. One is, how do I build the AI model? And essentially, to build the AI model, we need very customized hardware that chews up an enormous amount of electricity. And a lot of times this hardware runs for a significant period of time to actually compute a single AI model. And
Mm,
so, this could be Google or ChatGPT or any of these other leading AI companies saying, what's my next generation model? How do I pick what my data set is? And now I have like literally petabytes of data that I want to crunch through to build my new model. And so this might be running on like billions of dollars of hardware for weeks to months to actually compute this kind of a model. So inside that compute infrastructure, it needs to be super fast, super close together, very dense. But because of the length of time that it actually takes to run this stuff, that data center doesn't actually need to be near people, right? So these training data centers are often built in places that have cheaper power, more natural kind of cooling. And so these are not the facilities that we're placing in cities. These are very much the build these in a rural area kind of a data center facility. On the other side is now we have the model. Now you want to actually ask it, a question. Those are the inference machines. This hardware is much lighter weight, and generally speaking, latency matters. If you're typing back and forth, you don't want to ask it a question and have to wait 500 half a second for you to for your question to get to the other end, and then once they compute an answer for your answer to come back to you, right? That
Right.
latency would just kill the experience. So you want this inference hardware as close to you as possible so that you can have that more real-time kind of conversational experience. So we deploy these two kinds of hardware in very, very different ways. Like, so thinking back to slide 2, where we were talking about kind of the different facilities, the AI training software is almost all deployed in custom built, specially designed data centers owned by the big tech companies. The inference stuff is often in those colo facilities or those edge sites that are as close to you, the customer, as possible, so that you get as good of a user experience from interacting with AI.
Are those kind of like internet boosters? So if you live in a large home and the Wi-Fi is on the bottom floor, and some people have a second floor, and they put a Wi-Fi booster upstairs. Is that kind of a good analogy of that?
So you could think of edge sites as that kind of booster, yes, and the AI inference often sits in that kind of a site, just so that you get that better experience. Yes.
Okay.
So I
So,
think with the AI inference, it breaks down a little bit, but we'll go with it.
okay. I'm just trying to make it understandable for the people in the back like me.
Yep, yep. So then if
It's
we
so you see with the AI inference, the distribution data center, the workload, the latency, the hardware profile, are you gonna walk us into the geographic logic of inference?
Well, so again, the inference you want as close to the people who are going to be using it as possible. So this
Mhm.
is this is where your AI training data center might literally be in rural America, and
Right.
your AI inference stuff you probably want in your same metro, right?
Okay.
So that you
Do
have
they
as
have the
fast
same
of
power
experience.
needs, same cooling
No,
needs as a data center?
no. So inference is much less power intensive than the AI training side.
Okay. And then what about summing it up? The physical bifurcation of it, there's a
Yes. So this is really just to say, hey, there very realistically is two sides to the AI. You need both to make the AI work, but
mhm,
because they have very different characteristics of like power needs, cooling needs, as well as latency needs, we locate them in very different places.
we got slide 5. Are you ready for slide 5?
Go for it.
All right, let's see part
All
5,
right.
the energy bottleneck, why regulation is the new latency.
Yep. So this is really to try to peek a little bit more at the U.S. power infrastructure, right? And point one is like we have a backlog. There are places I think in Virginia where there is a 5-year wait time to gain access to the grid for an industrial facility. Like it is enormous. And so some of
Wow.
this is political drag. Some of this is because we just don't have enough power generation. Like
Mhm.
and so some of this is because we've been trying to lean green, and we just have not actually deployed enough new energy capacity. And so green energy, it's generally cheap. Wind and solar, we can actually per watt, I think, generate cheaper than we can gas, um, let alone coal. And, but at the same time, we have a problem with them. Wind energy only works when the wind is blowing, so it doesn't
Right.
give you power 365, 24 hours a day. Same thing with solar. Great during the day, but then what at night? Or what if it's a cloudy day and our capacity is diminished? Or, we're having a snowstorm and your solar panels are covered until it actually melts or you can clean them off. Like,
And the wind turbines freeze up.
yep. So there are very serious reliability concerns with that. And then battery capacity just is not cost effective. So we still need, number two, these constant load requirements, right? And data centers, that they raise and lower perhaps in their load requirements, but their range is very different than a factory that maybe works 2 shifts a day and shuts off during the night.
Wow.
Right? Your data center is generally chugging along 24 hours a day. Now, maybe during a US data center, probably has more load during the US business day than it does at night. But the power is less spiky. Let's put it that way, right? And so you generally need a constant load requirement for this.
What about modern clean energy delays?
Yeah, well, this is where we're really slow at actually adding stuff to the network. This is my little plug for nuclear energy, because nuclear is green and nuclear gives you that constant energy output. And so it's really easy to generate the same amount of power, 365, 24 hours a day with a nuclear facility. One of the other costs, I think, of much of the other green energy is we end up having to back it up with something. Okay, great. I put together a whole solar array, but then what do I actually do when I can't actually get enough power, like at night? Well, now I fire up a clean gas generation. And so I literally had to deploy all these solar panels and gas generation to provide that power. So I deployed twice the capacity, and I'm using each half of the time, right?
Right.
And so some of these energy policy things that we're doing are really hurting us. And it isn't only AI that's actually like moving in this generation. Like there are lots of people who are talking about, we can't switch over our entire fleet of vehicles to electric vehicles. I don't want to get into the electric vehicle debate, but we don't have the energy infrastructure for everybody to plug in a 50 amp charge at night. Like we can't do that. So what would we need to do for power generation, power transmission, power distribution to actually, handle electric vehicles, as the norm, let alone, additional data center capacity because we're adopting these new technologies. Right. So this is a problem bigger than data centers. And so, number 4, private market reaction, like the on-site power, bring your own power is very much turning into this popular thing. And so some companies are saying, yeah, I'll deploy my own. I'll get the licenses and whatever environmental permits necessary to run my own on-site power generation. Some facilities,
that's big dollars.
It does. It takes a lot of money to actually buy and deploy that kind of infrastructure. Some companies are like, well, we don't actually want to get into the power generation space. So we want to work with local power generation companies, maybe to build dedicated power generation facilities for our data centers. And then I think, another one of the interesting things here is like, people are worried about data centers driving up their power prices. And there is some validity to that, right? Increased demand with limited supply means prices increase, right? Basic economics. At the same time, it's generally the case that, industries who demand access to a power grid have to pay for access to the power grid. We don't force, retail customers to pay because a new factory is like, hey, I need 5 miles of high power transmission power lines put in. No, that's on them to actually pay for it.
Although that's the fear in a lot of communities. I know it was in Louisiana when they did their data center here. They found out at the data center is that who's going to pay for the power. Who's going to pay for the power transmission? Who's going to pay for
Yep.
the power lines? Who's going to pay for the infrastructure?
So
And
I
do
think
people work?
state laws can play into that on how that actually works. This is also one of the places where like there can be subsidies where the government's like, oh, we'll pay for that for you. The taxpayers are on the hook. And
Exactly.
that's probably not a
Or
really
now
good
when you get
thing.
your power bill, there's a little sub line that says, $1.50 to the AI data center,
Uh-huh.
facility or whatever the case may
And
be.
that is not fair to the American public,
Right. Which goes
right?
back to what I'm saying is that I think, data centers exploded all into our how shall I say, into our daily lives news story, into our news stories, like all of a sudden, like I didn't even know about data centers until, probably a year or two ago. I wasn't aware that I guess I just didn't really think about it. I knew that there was probably, big, floors of buildings that had, banks of computers in there, but I had the data centers where they're clear cutting, hundreds of acres of trees, using our water resources, really exploded on the scene. Politicians are giving them special credits and tax incentives and breaks and everything like that. And so it kind of turned me against the data centers. But then as I've done this deep dive, this will be my third podcast on data centers.
Mhm.
I've more and more I've opened my eyes and said, well, we can't be against them. They're powering our technology. So how do we take a positive approach and wake more people up and in a positive way interact, publicly or with these people in these data centers in such a way we say, hey, look, if you can be a good steward of our environment, if you can find a way to give back, which these are companies that are worth billions and billions of dollars, and we're finding that they have excess heat, which we know can be used, or other things that can be used in our communities. If they can offer a way to give something back, I think this world could really embrace it, which we're just beginning. I mean, look, the Industrial Revolution, with manufacturing came out, it was polluting our waters. Hence, then now that comes the EPA and they're polluting our air. And once we got those in check, society embraced the Industrial Revolution and manufacturing. I think that can happen with AI data centers if more people wake up and get involved in a positive way. Sorry for my rant on that.
No, that's good. And we'll kind of touch on that, I think, as we talk over slide, image number 6, if you want to go to part 6.
Before we go to number 6, let's talk. I want to find how do these guys make money? I mean, common sense tells me there's Chat GPT, even though there's a free version, you have to buy credits. I'm sure
That's a really
Facebook's
really really good
you
question.
Facebook ads, I'm sure. I mean,
Yep. So
you
some
talk
of
while
this
I'm on
depends
6.
on the company that you're specifically talking about. Like, Meta is, hey, we're going to build this social media platform so that we get users so that we can show ads to you. And we're really showing ads. Google search, that is still the main model. Hey, you're going to go perform a search. We're going to show you some ads. And that's how we actually make money. Subscriptions are actually creeping in as a good way to make money for end user consumers.
Right.
You and me as personal people. And then, companies like ChatGPT, Claude, Google with Gemini and things like that. There's also their whole cloud branch and their AI kind of for enterprise. Like if you own a company and you want to add AI features to your thing or add AI to your processes that your employees use, right? There's ways, APIs for people to actually code that into the software that you use, and then you're going to be paying Google or you're going to be paying OpenAI or whoever is it, Microsoft if you're using Copilot behind the scenes, right? For that compute capacity that you're using inside of your business. And so there's really a number of different revenue drivers. Now, I don't actually have hard data on this, but I suspect that most of the AI use up until very recently has been highly subsidized by these businesses, meaning they were not charging nearly enough to actually recoup the costs. And some of that was like when a new technology comes out, you want to jump in, you want to grow the market, you want to make sure you get your market share before you actually start trying to collect on it. And so I suspect many of these companies have actually done that. And then I think as another part of this, the technology, the chips that are actually being deployed to do both the training and the inference have been iterating so quickly that I suspect some of these platforms or technologies are actually obsolete before they actually paid themselves back. And so I think some of these big companies have just drained billions of dollars trying to build the infrastructure for this, build the market share for this. And then we're going to see more monetization aspects of this coming over the next couple of years.
So is this gonna be kinda like the drug dealer? They give you the drugs for free and then, little bits, and then when you get enough people addicted, then they start charging you for it, and then when you're really addicted, they charge you more for it? I hate to make that analogy, but,
Well, if the shoe fits, but I mean
yeah.
that has been a very common way to do things for a long, long time. Like way back pre-year 2000, like you would get software that would get passed around literally on discs, and right there would be a demo version of it that would work for so
Oh,
many
yeah, I
days,
remember
or
that,
there would
yeah.
be feature crippled or things like that, and then you would have to pay for it if you actually want the full license to be able to permanently use it and things like that. And so that kind of a model has been in use for many, many years. Like, hey,
Or is this
big grocery stores, loss leader. I'm gonna list some things for sale on my sales circular that goes out to everybody that actually bring people into the grocery store, and I'm gonna lose money selling every one of those things, knowing that I'm gonna get more money out of them for all the rest of the things that they're gonna actually buy when they're here. So,
or is AI just gonna make our life so much easier that and it's gonna make not only life easier, but but AI is gonna become easier for more people to use, that they'll just make their money off of volume instead of the individual, charging the individual a lot of money.
we'll see. I don't know how this is gonna play out.
All right, so
I don't really have a prediction.
let's go to number
Yep.
6. Stewardship and liberty, one of my favorite words, a frontier for digital flourishing.
Yeah, and so I think inside all of this debate, it's useful to step back and understand, you know, technology is not our enemy. Actually, technology is our friend in taming this harsh world that we live in, right? And whether this is new disease resistant grains that we develop, whether this is new cancer treatments, whether this is AI boosting labor efficiency, right? All of these things are things that hopefully allow us to do more in less time and conquer aspects of nature that are just hostile to human flourishing. And so we shouldn't look in inherent hostility towards AI. It is a technological tool. And sometimes tools can be used badly, but generally speaking, they're there to actually improve our lives. Right. And so we should start thinking about that from that frame of reference.
So kind of like we've been saying along, the underlying theme is if we can find ways to wake more people up on the benefits and become proactively involved in a positive way with these corporations, and more people are there more right now. I think that people waking up, it's more reactionary to
It is.
these news stories of they're clear cutting 500 trees and using our water, and we're all going to die because we don't have any water left. And instead, I guess, educate people more. And then, of course, by educating people more, it's kind of like voting. I always say, the reason why politicians get away with what they get away with is not enough people vote, not necessarily getting enough people to vote politicians out that aren't doing the right thing. But if more people voted, politicians would realize that the people are paying attention and they wouldn't try to get away with what they get away with because they knew they couldn't, because people are aware. So the power of voting isn't necessarily in making or getting your candidate a victory. Voting is powerful because it lets the politicians know that more people are paying attention. Much like the
Mhm.
data centers, if we get more people together, showing up at the commission or the meetings and the town hall meetings, and instead of saying screaming down with data centers, no to our private property rights, we want to save our property rights, instead saying, hey guys, if you all can return that heat back to us through geothermal, if you guys can plant more trees in our cities that you had to take down, if you can do XYZ, we can be partners together. Is that kind of the thought process?
Yeah, I think there are certainly aspects of that, and then it's also valuable to think about the jobs that are provided with these facilities and things like that. And then kind of jump into point two here, which you touched on,
Yep.
that some of
Private
the
property rights.
NIMBYism is really private property rights are the solution to that. Hey, we're concerned about water. Water is kind of a weird communal resource because if you pull too much from your land next door to mine, you might dry up my land. How do we solve these things with clear property rights? um, Electricity, right? You know, I shouldn't be on the hook, like you were just talking about, that little extra line charge on your electric bill because some new business decided to build a facility inside the area that my power company provides. Like, no, they should pay their own way, right? So how do we solve these kind of conflicts with property rights? The noise problem. Well, generally speaking, it's really easy to solve the noise problem. The data center needs more space and needs buffer land around where their facility is and where they're creating the noise to the edge of the land so that their noise that they create on their land doesn't interfere with your use of your land, right? So,
You talked about, and while you're on the issue of property rights, in Louisiana, we saw the last legislative session, and with the governor's approval, give eminent domain rights to private corporations. And
that's
we saw
awful.
that
That
as
is
it
absolutely awful.
as it pertains to carbon capture, they gave independent companies eminent domain rights to pump carbon under the ground. And again, the analogy to AI data centers is there's a lot of people that are coming out against the AI data centers because they're worried about, of course, again, we've talked about pollution and water rights and all that other stuff. And it's the same as with carbon capture. But again, we have politicians giving these big corporations special tax incentives, stealing from the people basically to get themselves a flag to wave that they got something done. And we see that with, of course, the so carbon capture, but it all comes down to private property rights. I'll let you continue.
Mhm. Yeah. So, I mean, I think many of these problems actually become less of a problems if we have strong property rights. And so, how do we strengthen our property rights and use those mechanisms to actually solve these resource conflicts?
Right. Market signals versus corporate welfare. We we kind of touched on that already, but
Yeah, yeah, and so I mean, I just want to say, as a Christian libertarian, I think it's absolutely wrong that governments are giving handouts to these large companies that are already profitable to say, "Come build here," versus building elsewhere. No, a company should have to pay their own way. It's fundamentally unfair to have these kind of tax abatements for these billion-dollar companies when the little mom and pop shop down the street doesn't get any tax abatement, right?
right.
So I mean, we could rip into this, but right, we need true price signals for these companies to make good decisions, and we don't have real price signals when the government is stepping in to give these kind of rebates or things like that.
Well, let's wrap up this last infographic with creative destruction and embracing the shift.
Yeah, every new technological leap ends up changing what the job market looks like. Um, you know, we kind of talked about industrialization a little bit earlier, but right at one point in time in our not so distant past, 97% of Americans were involved in agriculture. And now it's something like 3% of Americans are involved in agriculture. It is completely flipped in 150 years, right? And then we
Right.
went through our manufacturing and industrial phase. And then we kind of went into the information age. And now we're entering the AI age. And there's going to be changes to things because of that. Jobs are going to become obsolete, stuff changes. Rather than fighting against that, we need to understand that that is actually a net good thing. And yeah, it is hard if you lose your job because of this. I get that. Like,
Mhm.
this is something, frankly, AI has been coming after programming jobs. And so I look at this and I'm like, am I going to have a job in 5 years? And yet, in the end, it is a net good for society to have these technological leaps forward.
It's
Um,
gonna open new doors and it's open some new jobs. It's gonna open up some new
yeah, it
things for
will.
some people.
Yes. Yep. And then
But like
not on this image, I kind of wanted to walk through one last point, if that's all right with you, William.
absolutely.
Okay. So I'll pull this back into data centers, but let me walk through something, starting with
It's
a
not on this
guy
image you
named
said, right?
not on this image. You can take this
Right.
down if you want.
Okay.
Um, Something called the broken window fallacy that was introduced by a French kind of philosopher named Friedrich Bastiat. And he defined the broken window fallacy. It's the mistaken belief that destruction stimulates economic growth by forcing people to spend money. And so the illustration that he used was a vandal breaks a shopkeeper's window. The shopkeeper then has to go buy a new window and have it installed. And that creates jobs and circulates money locally. The problem is, when we look at that, what we don't see is the opportunity cost. Well, that shopkeeper originally had a window and had some cash.
Right.
After that window was broken, he had to spend his cash, and now he just has a window and doesn't have the cash, right? So he could have used that cash to buy a new suit. He could have had a window and a new suit. He could have bought, some kind of new equipment for his business and had a window and had new equipment. But now he only has a new window. Then a guy named Henry Hazlitt came along and wrote a book called Economics in One Lesson. And he expands on this idea of the broken window fallacy and kind of expands it into a universal rule. And that rule is this: true economic analysis requires looking beyond the immediate visible results of any policy to trace its long term hidden benefits or consequences. So the fallacy of the seen occurs when people focus entirely on the direct, concentrated benefits of an action, like, maybe a government subsidy keeps a specific factory open, or not building a data center means less water consumption in this particular area. The unseen represents the wider scattered costs or benefits. Maybe the private sector jobs that are never created because we didn't actually create the compute infrastructure they needed, right?
Right.
So Hazlitt argues that the fundamental difference between a bad economist and a good economist lies in this distinction. A bad economist only looks at the short run impact on a single group, while the good economist investigates the comprehensive long term ripple effects across society as a whole. So if we apply that to data center thinking, right? Yeah, if we don't build that data center at this location, maybe we maintain municipal water supply, or we preserve farmland or forest land, or maybe we keep our energy prices a little lower because there's less demand on our immediate grid. But we aren't looking at all the benefits that are actually provided by the facility. The jobs created require that to build it, to operate it, the benefit to every consumer of the AI or cloud compute that's actually deployed there. Maybe AI helps a school kid actually learn something that her teacher couldn't explain to her in a way that she understood. Maybe it helps a young man write a computer program that causes him to launch a new business. Maybe it helps researchers develop a cure for some disease, right? There are benefits to this that are very difficult and far reaching to see, where often the negatives are concentrated and local and very clear, right? But we actually have to consider both sides to really do a valid economic analysis.
And by considering both sides, we can find that symbiotic relationship that is good for the next technological revolution, if you will, and our environment, and then, of course, humanity in general too.
Right.
It's amazing. Ben, you've given us some exciting, good information, I think, and I love that your approach has not been. I mean, while people can watch this and go, well, that's kind of pro data center. It's kind of justify some things we'll say and be an advocate for the other side, so to speak. But when you listen to what you've said today, it really it's factual, it's straightforward and eye-opening in a way that I think it promotes that positive reaction that I think our communities need more of because it's not going away. Now, I will tell you, I've done shows recently where I'm worried about the flock cameras. I'm
Mhm.
worried about the collection of our data, and I'm worried that it's being done through many data centers. But from what you're telling me, it's not necessarily the data centers collecting information as much as it is the companies that might lease those data centers or have storage in those data centers. So, and like something you also said earlier, I don't know if you said this on air or if it was before, when you talked about one of the things that we can do to protect ourselves is if we're worried about data collection from certain companies, just don't do business with that company.
Yep, don't do business with that company. Use encryption. Like, make sure nobody can actually read your data but you or the other person for whom that data is intended. Like, yeah, there are things that you can actually do. And if you're super worried about privacy, uh, big tech companies, they make their money because you're the product that they sell. If you sign up for a Google account, Google is providing that to you for free so that they can serve ads to you, and that's how they make money. Same thing with Meta. You sign up for a Facebook account so you can connect with your friends. Meta is like, no, the Meta's customer is the people who are selling ads to put before your eyes, right?
It's no different than buying from Amazon. When you buy from Amazon, you might think that they're making money off your product, off of buying a product from you, but the minute you sign up as a customer and you join their club and you become a Prime member, all you're doing is opening a door for them to serve you ads and more advertisements about products that they sell.
Mhm.
So,
Right? And
so,
so,
so
remember where you are. If you're not paying, you're not the
right.
actual customer.
Right. Ben, this has absolutely been amazing. I can't tell you how much I appreciate not only your information and knowledge, but your time. But I'm grateful that you spent it with me to share this valuable information. Do you have any one thing that you want to share with us before we close out?
Well, I mean, I hope the viewers here I got a different perspective, have a better understanding of kind of some of the choices that tech companies are making, why they're doing the things that they do. Um, I think it's really important, especially to understand the different kinds of data centers. And so, if you're in a position of making policy, you don't want to write a data center policy that maybe prohibits the large custom built facility and then prevents an edge site from actually being deployed that would make less Netflix buffering for the people in your community, right? So how do we actually think about the differences that actually exist here, and we think about things in more specific ways, and kind of in that same thing. Don't let your anti AI sentiment suddenly mean that you can't actually back up your data to the cloud. Like, like let's keep some of these things straight here. So, hopefully, by understanding a little bit more, by getting kind of that insider's view of what's actually happening, the different facilities that exist, why they exist, how we should think about things economically, you can actually make more reasoned conclusions about this and advocate for public policy based on that.
One idea to share with you, and then one last question. Idea is maybe we need to do a special podcast on for politicians on how they can work with data centers in the communities to make sure that our communities' rights, our property rights, and our environmental rights are both respected and working in that symbiotic relationship. Maybe that could be something that we could work on next. And the final question for you is, and where I usually ask people where we're losing freedom the fastest in America, and I think I asked you that way the first time. Do you think with this AI revolution, data centers, all these different edge sites, this different emerging industry and connection that's a boom in America right now and all over the world too? Is there a way that we can protect our freedom? Is there going to be a way that we can still have our freedoms, our privacy, and our liberty in a way that respects data collection, respects AI? That is there a way for us to be able to protect our freedom and liberty with this?
So I'm less worried about corporations in this aspect because I at least understand what they're trying to do. They're trying to make money off of me. I am worried about the government actually collecting various pieces of data and using AI to um, maybe combine data that they've never been able to combine before to build some kind of a profile about me that no human ever would have been able to create before. And so I think there are ways that we should be looking at how we constrain the government in this space, how we should strengthen, say, the Fourth Amendment and limit what data the government can actually collect on us. Um, Again, I'm less worried about Amazon or Google and my data than I am about the government and my data.
Ben, that's a mic dropper right there. Hang
Yeah.
on one second. I appreciate you, Ben. I really do. Hang on one second. I want to close out the show and I'll be right with you. I want to thank everybody for spending this time with us and thank everybody, especially for if you'd share the video. It means the world to me. I really want us to be awakened by facts and motivated by facts instead of being motivated by our fears or motivated about things that we don't know enough about. So I ask people to get informed on not only the data centers, but what our government is doing, what our politicians are doing, and find facts and fight back with facts instead of fears or just passions. Back up your passions with facts. Use your passion to fuel your energies to be able to get facts out there and work with the other side. You can't just fight against the other side. You got to work with the other side if you really want to get what you feel you need for our communities, our environment, but most importantly, our freedoms and liberties. Thank you again very much. And please share the show. And I'll have another one up here very soon.